Uh, Good afternoon, everyone. I want to welcome you to my lecture today. Of course, we started chapter 10, and today we're going to continue focusing on hypothesis testing that has to do with one population. Okay, so when you hear one sample hypothesis, the one sample actually indicates, we're working on just one group or one population, and we're actually choosing a sample from such population. So on Monday, you were introduced to hypothesis testing. Of course, the idea behind hypothesis testing is to be able to test the validity of a claim. Anybody can make a claim. So if anybody say anything, or if anybody make a statement, that doesn't mean the statement is going to be true or not. So every statement to me is an hypothetical statement that actually needed to be tested. And of course, in statistics, we got a way to, put whatever statement to test. And of course, I told you the other time that is synonymous with what we do in scientific world. In scientific world, we test if there's an agreement between observation and theory. Of course, the theory is going to come in form of hypothesis. Now, what we did on Monday, we focused on testing hypotheses about me. But today, the focus is going to be testing hypotheses about proportion. Of course, I told you earlier that when we actually want to figure out what is the true value of a parameter. Okay, and the parameter could be mean. Parameter could be mean, could be proportion. Okay, could even be difference of means. Could be difference of means. Okay, could be difference of proportion. Could be difference of proportion. If a parameter could also be variance or standard deviation. Okay, so let me just say parameter is whatever, it's a population characteristics of interest that we actually want to determine. And of course, we could have some people that have a kind of an hypothetical statement about what the value is going to be. Today, we want to focus on testing, hypothesis about proportion. And of course, I'm going to start by walking you through p-value in decision making. Of course, I actually introduced you to p-value the other time. I remember in my last class, I walked you through how to take a decision. using the p-value and at the same time using the critical score. Then I'm going to walk you through hypothesis testing involving proportion. Then I'm going to have an illustrative example. Okay, let me go to the p-value. Okay, the p-value, if you come across a research article, of course, a research article that make use of statistical techniques, whenever they conduct hypothesis, okay, you're actually going to see them indicating p-value. So p-value is actually is the probability that we observe an extreme values when the null hypothesis is true. When I talk about non-hypothesis, I mean HO, okay? The probability of observing an extreme value when the non-hypothesis is true. Of course, we normally make use of a level of significance of 0.05, and we compare p-value with the level of significance, and the decision is when we conduct any statistical test, okay, when the p-value is less than a given level of significance, then the non-hypothesis should be rejected. Okay, so when p-value, is less than alpha, alpha is a symbolic representation of the level of significance. Now, what do we mean by when I say level? When I say level of significance, what do I mean by level of significance? The level of significance is the level of statistical error. It is also called the maximum probability of committing type 1 error. We're still going to talk about error in hypothesis testing. We got type 1, type 2, we're coming back to that. But so if you give your level of significance to be 0.05, okay, that is 5%. It means in your research, you're actually going to mislead, the stakeholders like 5 times out of 100. That's an acknowledgement that your research is not perfect. Okay, when we're conducting research, we're making use of model. Our model cannot give us exact reality. There's always going to be an error. This is an acknowledgement of the fact that, okay, our research could also mislead. Now, when the p-value is less than any given level of significance, then what that means is that we have detected a difference. Okay? What that means is statistically significant. That's what it means. Now, I want us to have a motivating example on proportional. I told you the other time, there's always going to be, an investigation will always going to follow a claim. Whenever somebody make a claim, the next thing is investigation. Because when you make a claim about me maybe in a particular, maybe in a constituted authority, I know the authority is not going to punish me immediately. What they're going to do is to investigate. We do the same in science. Take a look at this. I remember between 1960 and 2002, there was a research conducted by Center for Disease Control, and in the research, they realized that between 1960 and 2002, Americans have gained weight. Okay? I think I saw an article where they actually discover that people in the United States, particularly men, have gained weight between 1960 and 2002. Okay, maybe that is the reason. Take a look at this guy now. Okay, take a look at this guy. A diet P company advertises that at least 75% of its customers lose 10 pounds, okay, or more within 2 weeks. I need you to take a look at the first statement. That statement is an hypothetical statement. Do you know why it's an hypothetical statement? Because it's a claim that has not been verified, okay? And every hypothetical statement needs to be tested, okay? So if you take a look at if you take a look at that guy there, at least, pay attention to this, at least 75%. How do we interpret at least in mathematics? Oh, go ahead.
P is greater than or equal to 75.7.
Exactly. Thank you so much for that. Send me a message for extra credit. Now, this is this, right? But let me tell you this. This is not going to go into the non-hypothesis. I told you what is going to go into the non-hypothesis is going to be a quality sign. But this guy will enable me to know what will be in the alternative, because what will be in the alternative is going to be the opposite of this guy. Does that make sense? So which means what, if you really want to know what will be in the alternative, you need to first understand what is in the non-hypothesis. Okay? Now, you can see a claim now, right? You suspect the company of falsely advertising the benefit of taking their P's. Okay? You know, it's normal. In real life, okay, there's room for suspicion. Does that make sense? Okay, there's room to doubt. Of course, it's normal. Why do we need to doubt? Because we live in a stochastic world. Okay, there's a variation. There's possibility. You know, at times when my wife is telling me something, I'm going to say, are you sure that is not a joke? But at times my wife joke. Does that make sense? That's why at times we can doubt somebody. Okay, so you suspect the company of falsely advertising the benefit of taking their P's, right? Suppose you take, which means you are now going into investigation. Does that make sense? Now, suppose you take a sample of 100 products, okay, or product users, and find that only 5% have lost at least 10 pounds. Okay, is this enough to prove your claim? Okay, now what about if 72% have lost at least 10 pounds? Now, let me tell you this. If I ask you to conduct this research, okay, and I ask every one of you, okay, your sample proportion will be different. That was why initially somebody said 5% have lost weight out of those people that use the P's from that company. Another person could conduct research and realize that it's 72%. That is not surprising. You know why? Because proportion, because statistic is a random variable. It varies. The same way mean varies, proportion also varies. Okay? And that was why we're doing something that has to do with sampling distribution the other time. Now, take a look at this. What is the goal? Okay, the goal here is to use sample data to formally test hypotheses about unknown population parameters. Of course, the unknown population parameter here is P. We're talking about proportion. Okay, that is what is unknown. Okay, we don't know it. Okay, and what we need to do is to take a sample of data, okay, and investigate. Now, whenever you are working with hypothesis testing, okay, we got procedure. Okay, procedure number one. Okay, you formulate both the null and the alternative. I need you to take a look at this. This is not in the question. How do I know it's going to be less than? Because the claim was greater or equal to. The opposite, okay, the complement of the opposite of the claim, the opposite of the greater or equal to, is what you're going to put in the alternative. Like I said, you are not going to put greater or equal to in the alternative. You're going to put equality. But we know by principle, what we have here is greater or equal. Does that make sense? Okay, because if you want to get the alternative right, you need to first get the non-hypothesis right. Now, this, the specification of both the non and the alternative hypothesis. Why am I writing 0.75? Because proportional result can be given in different ways. Proportion can be given in percentage. Proportion can be given in terms of fraction. And I could remember in middle school where you do like percentage, fraction, stuff like that, decimal. There are different ways to actually represent proportion. Any question about this specification? Any question? Like I said, do not hide your feelings. If you don't have A up to now, I want to believe the moment you spend more time with the final, you're actually going to get A. Final has a huge weight. And whatever we're going to be doing now, very, very crucial. And that's why I need you to ask me a question the moment you don't understand. Okay, now after that, okay, so we have this guy now. Now the next thing we're going to do is we want to conduct a test, but I first want to tell you what is the meaning of this guy. That's a PCAP, right? Do you know that if we want to investigate just the way we've claimed, okay, and I ask you to go into population, okay, take a look at this. I give you this assignment. If I give you this assignment to go and look for those who use the P from this company, okay, I want to believe, and I ask you to select 100, right? If I ask you to select 100, and I actually want to see how many of the 100 has lost 10 pounds, I want to believe you're all going to get different results. Because you're actually not going to be using the same participant. Does that make sense? You are choosing at random. And because of that, this guy here, which is going to be in your own sample of 100, if you want to compute that in your own sample of 100, now take a look at this. In your own sample of 100, this is the formula you want to use to compute that. This is going to be 100. X is going to be the number of participants in your sample that have lost 10 pounds. Does that make sense? Now, if I have 1,000 students here and you do that, you actually, the value of this guy is going to what? It's going to vary. Does that make sense? And when it varies, I told you the other time, we're using the principle of, central limit theorem, provided we choose a sufficiently large sample. And how large is a large, right? At least story, we're actually going to realize that this guy here is going to follow normal distribution. When you follow normal distribution, okay, when I try to find the average of all of what you got, like if I, like here now, P cap 1, P cap 2, until I get to P cap 1,000, I'm just assuming I have 1,000 students, right? And there's going to be variation here, right? The mean of all of this, the average of this, okay, is actually the average of that, okay, is what we are trying to hypothesize. The P0 here is the value under hypothesis, right? Then this guy here now is going to be standard deviation. Now, I quickly want to say something now. Before we've done confidence interval for proportion, right? And what we're doing now is hypothesis testing for proportion. Okay, now inside here, what we normally use here, the P that we normally use here for the interval estimate is going to be P cap. You remember? When we're dealing with the confidence interval, okay, we're okay, take a look at this. And let me quickly remind you. You see that? What did I use inside here? It's the same P cap, right? But when I'm dealing with the hypothesis testing, okay, we are not going to use, inside here is going to be an hypothesized value. Does that make sense? And that is it. What is an hypothesized value? 0.75, the value that you specify in the hypothesis. That was why, so there's a difference between confidence interval for proportion and hypothesis testing for proportion. Okay, now, at the end of the day, mean, standard deviation, then I'm going to go to the test, okay? The t-test is going to be sample proportion minus an hypothesized value divided by the, and what you're going to see here is the hypothesized value. Now, I'm going to plug that in now. Okay? Now, you see, 0.75, I've already, here, P cap is the proportion you get from the sample, and you've been given here. You see that? Suppose that in your sample of 100 customers, 65% has lost at least 10 pounds. Does that make sense? That is your sample proportion. So you can see that now. Now I've plugged that in. I plugged that in. Finally, I got a negative 2.5. But let me tell you this. When I'm dealing with the proportion, hypothesis testing on proportion, go ahead. You say what? Oh, okay. I'm going to say something now. That was what I wanted to say now. You can see I actually write T, right? Now, for proportion, when you are dealing with proportion, T is the same thing as Z. Does that make sense? You can see me here, right? T and Z. Okay? So we actually, it's going to be the same as Z. So I'm going to be focusing on Z. Now, what do I want to find here? I want to take a decision, right? And how am I going to take a decision? I want to find my p-value. I told you the other time, if you want to find your p-value, okay, please listen. If you want to find your p-value, you actually, it's going to be Z less. Where is the less coming from? Whenever you want to find the p-value, then you should go back to the alternative. Let's go back to the alternative. Now, do you see alternative? The sign in the alternative must be put into consideration when you want to compute the p-value. Does that make sense? Whatever sign, you can now see it's very easy to score everything in an hypothesis exam, and it's also very easy to lose all the points. You know why? If this is wrongly specified, okay, if this guy is wrongly specified, automatically, even if this guy is right, even if this guy is right, you're only going to get a grade for, a credit for this. But this guy, It's also going to be wrong because you may not be able to know what, the moment you wrongly specify the hypothesis, of course, you're actually going to have your p-value wrongly computed. You see the sign now. And now I'm not going to make use of my normal table. I'm going to find, okay, I want to find, p z less than negative 2.5. When I check from my normal table, that gives me a 0.062. Of course, in the exam, I'm going to allow the use of table. In fact, you do not need to come with tables. We provide the table in the final. Does that make sense? Okay, now, since p-value is this, take a look at the p-value now, right? P-value is this. For us to be able to take a decision now, we're actually going to compare this p-value with the level of significance given. Now, if you go back to the question, let's see whether they gave us a particular level of significance. Now, the level of significance was not given here. Situation where the level of significance is not given, we have a standard value that we normally use. Is 0.05. Does that make sense? That we call 5%. Okay. Now, if you take a look at what I have now, okay, if I compare the 0.0062, let's say with the alpha of 0.05, this guy is going to be less, right? And when the p-value is less than a given level of significance, the non-hypothesis will be rejected. Now, what was the non-hypothesis? Don't forget, the non-hypothesis is actually HO. Okay, the non-hypothesis here is the claim. The non-hypothesis here is the claim of this company. But right now, you are rejecting that. Rejecting the non-hypothesis, it means your conclusion will be in favor of the alternative. Does that make sense? It means your conclusion will be in favor of the alternative. Now, if you want to conclude right now, what you're going to say is, is that if you take a look at this, it means there is a sufficient evidence, okay, to conclude that that HO is false. What the claim is incorrect. That's what it means. Okay. So is there anyone who actually want to ask question? Who need clarification? Is there anyone? Okay. Now we assume that HO is true and put the burden of proof on that. Therefore, we can use the p-value. I think I just said that now to take a decision. Okay, so we can use the p-value to decide whether or not data provide sufficient evidence to reject HO. So in this research, now there is a sufficient evidence to conclude that the statement is false. And that's why you need to be careful when you get information. The world is full of misinformation and disinformation. So always make sure you verify whatever anybody tell you. Okay? And of course, small p-value. Okay, when p-value is very, very small, there's possibility the non-hypothesis could be rejected. But we don't know how small it is. But the fact remains, compare your p-value with the level of significance given. There's always going to be level of significance that will be given. The moment you are not giving, you're going to use 0.05. Okay. Now, I think I just told you right now, when p-value is less than alpha, we have a strong evidence against the non-hypothesis. Then when p-value is greater or equal to, we fail to reject. Now there's something I'm going to tell you. Don't say we accept. There's a difference between we accept and we fail to reject. Even though I know when you want to look at it from maybe English perspective, you may be thinking that failure to reject means acceptance. I know, but in statistics, in science, we don't say that. When you say that, so when the null hypothesis is true, we normally say we fail to reject. We don't say we accept it. Does that make sense? But we failure to reject means we do not have a sufficient evidence to do so. Does that make sense? Yeah. Go ahead.
Is alpha always equal to 0.05?
Not always. If it is the standard one is 0.05. You know, at times we could give alpha to be 0.01. You know, but the reasonable one, because 0.01 is more or less very close to perfection. You know, so when the alpha is 1%, means you are 99% confident. Oh my God, 99% confident in a stochastic world. That is, you know, that's what I mean. So that's why we normally want to like use prefer 0.05, which is like we are 95% confident. Okay, go ahead.
So on this last question, we use 0.05 and we should use it like going forward.
Yeah, like in this question now, they didn't give his level of significance. Even though in my exam, I'm going to give you level of significance, but in a situation where you are not giving, the standard one is 5%. That will call 0.05. Oh, you're welcome. Okay, now this is what I just said. This is what we just said now. Take a look at this. Alpha can be any of that. 1%, 5%, 10%. 1% means you are 99% confident. 5% means you are 95. 10% means you are 90. Does that make sense? So there's possibility when you conduct a test, when you use different level of significance, there's possibility you could take a different decision. Does that make sense? Because I can tell you, I'm 90% sure, and if you say, okay, what about 95%? I'm say, no, I'm not 95% sure. I'm only 90. So depending on the level of significance used, there is possibility. If you use, let's say in a test, you use this, you compare your p-value with this, there is possibility you could take a different decision using different level of significance. Now, when you are conducting a hypothesis about proportion, just like what we did the other time under mean, there's possibility the alternative may be less than, greater than, or not equal to, just like the same thing that we experience when we're talking about mean. And of course, this and this is one T test. One T test. This is a two-tailed test. Two-tailed. What do I mean by that? A two-tailed means it could proceed in both directions. That's why it's two-tailed. It's not directional, and these are directional. Okay? Okay. Now, and of course, we always have a test statistic. That is the formula. This is a test statistic. Okay? So please take note of that. And of course, there's going to be a p-value. This is showing you p-value that corresponds to a particular test. When I'm dealing with the less than, what do I mean by less than? Oh, what determines less than, greater than, two-tailed is the nature of the alternative hypothesis. You can see alternative. You see alternative. The null hypothesis is always equality. Does that make sense? The null HO is always equality. Okay. Now, there's a connection between computing p-value and alternative hypothesis. So that's why if you take a look at this, this is going to be a p-value for hypothesis 1 when the alternative is less than, a p-value for hypothesis when the alternative is greater than, a p-value for the hypothesis when the hypothesis is two-tailed. Does that make sense? That's what I'm giving you now. And of course, general way to take a decision, comparing p-value with the alpha. Alpha means level of significance. Okay, level of significance means the level of statistical error. Okay, now when p-value is less than alpha, we reject HO. When p-value is greater or equal to alpha, we fail to reject HO. If you take a look at this, we didn't mention HA. Did we mention alternative? No. We're only taking decision about the non-hypothesis, about HO. But we all know if we reject HO, our conclusion will be in favor of the alternative. If we fail to reject HO, our conclusion will be in favor of the non-hypothesis. Does that make sense? Okay. I want to go into another example now. Let's take a look at this example. Okay. Now, the manufacturer of a new breast cancer screening method claims that it detects cancer in more than 83% of women who have it. More than. I need to take a look at that. More than 83%. Okay? Now, when you see more than 83% who have it, say, to investigate, they apply their screening method to a sample of 203 randomly selected women known to have breast cancer. Now, the test detects cancer in 184 of these women. Now, 184 of these women use this information to test their claim at a 0.01 level of significance. Now, if you take a look at what you see on the board, you know, a claim can be in the non-hypothesis. A claim can also be in the alternative. Does that make sense? It is not all the time that a claim will be in the alternative. A claim can be in the no, a claim can be in the alternative. Now, I need you to pay attention to this now. More than 83%, that is greater than, right? It means, and where can we have a greater than sign, strictly greater than sign in the alternative? Which means the claim here, the claim in this question is in the alternative. But the claim in the, let me see, the claim in the last question, let me see the claim in the last question. You know, in the last question, it said at least, right? It said at least 75%, right? We said it's going to be, in principle, this is like greater or equal to. Where is the claim? The claim is in the no here. Does that make sense? So a claim can be in the non-hypothesis, a claim can be in the alternative hypothesis. All what I just need you to understand is this. On the non-hypothesis, it's always going to be equality sign. In the alternative, it can be less than, greater than, or not equal. Don't make a mistake. Under this, no this. Under the alternative, you're not going to have this guy. Only strictly less than, strictly greater than, and not equal. And the non-hypothesis is always going to be equality sign. Now, let's move it forward now. Going to the question now. Okay. Now, let me first tell you this. You know, I told you the other time, every statistical test has assumptions, right? Now, assumptions here is, if I want to conduct this particular, if I want to conduct a proportion test, the number of successes and the numbers of failures have to be at least 10. Some may say at least 15. Okay, now, what are you going to do? What is this? N. N multiplied by P. You remember that? We did the same under the N. P must be greater or equal to 15. N into 1 minus P must be greater or equal to 15. Now, if you want to investigate that, N, 203 is the sample size, P is a 0 point, and what you get is 168. It's greater than 15. And we do 203 times 1 minus that. That will be 35. It's also greater than 15, which means that condition is satisfied. Now, this is your hypothesis. Okay, formulation. Is there anyone who doesn't understand how this is formulated based on the question? Go ahead.
Can you explain what's greater than alternative?
Oh, you mean right here, right? This is absorptions. Absorptions. Okay. NP, this one means number of successes. And this one means numbers of failures. You remember we also did something like this when we're constructing confidence interval about proportion, but that one was NP greater or equal to 10. You remember we also did something like this under normal approximation to binomial. This is just an assumption to make use of a Z test for proportion. Does that make sense? Now, this is it. Let me tell you how they arrive at the 15 is from here. You know the central limit theorem, put it to be what? At least theory. And P, okay, proportion used to be maximum at 0.5. It's 0.5 times story. Can someone tell me? That's going to be 15. Go ahead.
I think he was saying in the alternate hypothesis why you don't flip the sign like we did in the other problem.
Oh, is that what you mean? Oh, why I did not put what in the alternative? Oh, why I did not put less than sign? Yeah, I'm not going to put less than sign because look at that. The manufacturer of a new breast cancer screening method claimed that. Take a look at this. How can you interpret more than? That's a greater than sign.
So you're saying if it's at least, then we're gonna put it. We're gonna flip the sign, and then if
That's a very good question. I'm going to do because of what you just said now. I'll quickly do this. Now take a look at this. At least, at most, this is this. This is this. Now, anything this will never come under the alternative. They will be taken as what? They will be taken as equality. Under what? Under the non-hypothesis. But what are the signs that we can have under the alternative? Less than, greater than, not or equal to. Now, if you take a look at it, this one means less than. This one means more than. They can say this English in so many ways. More than, exceed, greater than is still the same thing. Now, in this question now, look at what they say. It means in this question, you have been directly given the alternative. Does that make sense? Your alternative is greater than here. But in the last question, what did they say? At least. Now, they gave you this, at least, but you cannot write this in the no. You're going to write this, but this will enable you to know your alternative. Your alternative now is going to be the opposite of this. What is the opposite of greater or equal? That will be less than. Does that make sense? I've answered your question now, right? No, it's more than. This is more than.
In the question it says more than.
Yeah.
saying that if the claim includes equality, then it's gonna go to the null. If it doesn't, then it's gonna go to the alternate. Does that make sense?
Yeah, that is it. Do you know what I need you to know? What I just need you to know is what sign. Forget about this. You can have billions of questions, right? What signs can we have in the alternative? We just want to know. The sign in the alternative, this, or this. What sign can we have in the null? Only this. Do you understand that? The moment you know this principle, like the sign that is tolerated in the alternative and the one that is tolerated in the null, you're actually going to be fine. Now that in this question, now they mention more than then it should be interpreted as a greater than. And where can you have a greater than? In the alternative. Of course, you already know what it's going to be in the norm. All the time, equality sign. Does that make sense? Okay, now we do the same thing. We do what we normally do. You see, what am I calculating here? 184 over 203. You know, the other time, you were given the sample proportion. But this time around, you are the one that compute the sample proportion because you sample 203. And out of 203, 184. Look at the question. See, the test dictates cancer in 184 of the women. How many women did you use? You used 203. Then the sample proportion is going to be the number that you detect divided by the total. That was why you have, you got that guy there. That was why you get it. Take a look at this. Okay, and this guy is the P0. P0, the value under the hypothesis. And that P0 is what you're going to have here. Do you know mistakes students normally make based on my more than 15 years of teaching? You know the mistakes students normally make? They will go and put the sample proportion here inside the square root instead of the hypothesized value. Whenever you are conducting hypothesis testing about proportion, what you're going to put in the square root should be hypothesized value, not the sample proportion. But when you are constructing confidence interval, what you're going to put in the square root will be sample proportion. Now, why do I have a greater than sign here? Can somebody tell me? Why do I have a greater than sign here? I think over there. Why do I have a greater than sign? I want to compute the p-value. Why do I have a greater than sign here? Now, I want to talk about this side. Why do I have a greater than sign? Can somebody tell me? Why do I have this sign? Why not less than? Why do I have a greater than sign? Yeah, go ahead.
Is you say greater than?
Yeah, why? Why do we have a greater than sign here?
It's for our alternative hypothesis. We're doing a greater.
Because of the alternative. Send me a message for extra credit. Good job. Take a look at this. Let's go back to the alternative. What sign do we have here? Do you see the sign? The sign is a greater than sign. That is the reason, do you know why I said you should listen? Is because the moment your hypothesis is wrongly formulated, your p-value will be wrongly computed. And of course, when you have a greater than sign, when you want to go to normal table, right? When you check for this value, you're going to subtract from 1. You remember that? You're going to subtract from 1, subtract it from 1, that gives you this. Now you get a p-value now. Now, you get your p-value now. Do they give us level of significance? Yes. Look at that. It's 0.01 level. You're giving level of significance now. Let us now compare our p-value that we got with the level of significance. The p-value here is 0.002. It's less than 0.01. So when the p-value is less than a given level of significance, what happens? The non-hypothesis should be rejected. When the non-hypothesis is rejected, what happens now? Take a look at this. Non-hypothesis rejected, it means we are here. We're rejecting the null here. What happened? Where is the claim here? Where is the claim according to the question? The claim is right here. Then it means this time around, that claim is right. Okay, which means it's true. More than 83% of the women who have it, they're able to detect cancer. That means their approach is working. And that hypothetical statement has now been verified. Does that make sense? And that was why. Take a look at that. We reject HO at the 0.01 level. Please see the way you're going to be interpreting. Okay, now interpretation. We have enough evidence to conclude that the true proportion of breast cancers okay, dictated by the new screening method is significantly greater than 83%. So which means the claim here is actually right. Any question? You know, the takeaway here is a claim can be in the null hypothesis, a claim can be in the alternative. What I will advise you to do is always make sure you understand question. Internalize the question, digest it, trying to understand what the question is talking about. Because the whole thing is going to start from hypothesis formulation. The moment you get your hypothesis wrongly, it's just like a court. A court that got the hypothesis before them wrongly, the case before them wrongly, that very court will not take a good decision. Because in the first place, I think I remember also say, when the premise of an argument is wrong, so the conclusion. Okay? Premise, when the premise of an argument, okay, is wrong. It's wrong. So the what? Conclusion. When the premise of an argument is wrong, then the conclusion will be wrong. When your hypothesis formulation is wrong, then the decision you're going to take is going to be wrong. Don't forget, you need p-value to take a decision. Of course, this is coming in the final exam. I told you 60% of the final is actually going to cover chapter 8, 9, and 10. And we use this a lot in research. This is where I'm going to stop today. I'm going to continue on Friday. Be sure you stay safe and have a lovely day. Bye for now.
I got some other classes. Oh, yeah. I also managed to in the class. I can be honest. So